graphics technology with the special emphasis in animation. As Dr. Young said, I've been a designer here for 11 years. I started as a visual designer for the Exhibits Design Center within AgCom, and then I've been a senior multimedia designer since 2019. And I've been working remotely for the past 4 years. So I'm located up in South Bend, but I do make trips down here monthly or for events such as this. So over the past 11 years, I've worked on a variety of different projects, educational video games, large-scale print projects, multiple children's exhibits, augmented reality applications, and most recently, VR applications. So that's probably why I'm still here. I get to do a lot of cool things, and the work is always interesting. So, why virtual reality? A few years ago, our department head came to me and decided we wanted to start doing something a little more innovative. So, I pitched the idea of doing a VR project for food science that you could, for example, for the food science project, we essentially shrunk the player down to the size of a micron and then let them kind of analyze and explore bacteria and microbes that they use in food production. And that was kind of a really unique way to sort of, let kids see, how different these bacteria are, how much different they are in size and shape. So just examples like that are the kinds of things that we're interested in doing. It's a fast growing technology. I think this year alone in the US, there's 77 million VR users and 171 million users globally. And those numbers are projected to rise through 2030 and beyond. And a lot of that is just due to the technology getting faster and smaller and cheaper. So there's way less barriers to entry than there was even 6 or 7 years ago. So in-house, we have a suite of production tools that we use to build our interactives, Creative Suite, Maya for most of our 3D work, and then the Unity game engine is the platform that we use to develop our games, both traditional and VR applications. We also started using 11 Labs for AI voice generation. For a long time, Stacy was our, designated voice actress for a lot of things, but she has better things to do than to stand in a sound booth and, regurgitate lines all day. So we decided to give her a break. So our current target platform is the Quest 3, the Meta Quest 3, for a number of reasons. One, it's entirely portable. So you don't need a workstation or a PC or a tether to use it. It's just the headset and controllers, and you're good to go. It's considerably more affordable than some of the other headsets on the market, and it's widely available. And I was curious as to how much of a market share that the Quest 3 has. And as of Q2 of this year, it has a 74% market share compared to all the other brands. So it's by far way ahead of anything else out there. So if you want to reach a wide audience, this is pretty much the platform to go with. So Apple earlier this year released the Vision Pro, which a lot of people were actually asked us about back in February at the conference when we presented their first module. And the interest in that kind of tapered off because it's a $5,000 headset and it's only capable of augmented reality. It doesn't do any VR work. So for us, for our work, it wasn't really an option anyway. But the Quest 3 is only several $100s. It's much more affordable for the average consumer, and so that's why the market share is so much higher for it than other devices. So for our work for the plant science, we started talking about this project back in the middle of 2023. It was Aaron Robinson and I were discussing what we wanted to do next. And, we had just wrapped up our work with food science, and we knew we wanted to do something with the folks over at plant science. And, we started talking about, the phenotyping facility, how unique it is and how, much of an interesting, and standout place that Purdue has. And, how can we, what can we do to kind of promote that? So we sort of settled on like doing a VR simulation of the phenotyping facility itself. So, we really just wanted to immerse users in that environment and, kind of highlight the important features of the facility itself, as well as the data that they derive from the imaging that they do there. And then, we wanted to present that information as clearly as possible. So for the first iteration of the app, which we released back in February this year for the NAPPN conference that was held at Purdue, we focused specifically on the imaging center, and which consists of the RGB, the hyperspectral, and the X-ray imaging booths. And you can kind of see up there, I've got the blueprint of the actual facilities layout, and it's kind of in a circular. It's kind of laid out in a circular fashion because they can move plants in between different booths depending on what experiments they're running or what images they need to take. But for VR, we wanted to simplify it to make it easier for the user to navigate. So rather than doing an exact one-to-one replica, we decided to create a more linear experience and laid it out, with the RGB, the hyperspectral, and the X-ray booth in that order, which you can kind of see here. This is like the virtual layout. So it's just, you can go through straight and it's a bit easier to navigate for most people. For this, we wanted to highlight the important data points derived from each booth. And we did that using graphs and images accompanied by short audio clips, which I'll show towards the end. And then we also wanted to show a root system in VR. So one cool thing they can do there is they can actually use the images that they take and generate a 3D model of the root system of these plants. And so we thought it would be cool if we could take that and optimize it and bring it into VR, which we were able to do with the tools that we had. So for this past October, for the International Plant Phenotyping Network Conference, we wanted to add in one of the growth chambers. And we added it to the existing app, and in doing so, we kind of changed the sequence of events. So now the user starts in the growth chamber and then progresses through some interactives and then makes their way into the imaging center. But unlike the imaging center, we decided to keep the layout and scale as close to the original as possible, while restricting the movement of the player. And if you've ever been in there, there's not a whole lot of space to move around. It's mostly a series of conveyor belts. There's a little bit of floor space to walk around. So we decided that we could keep the user in one place, have them do a few interactives, and then move them along to the imaging center. The goals here were basically the same. We wanted to highlight features of the growth chamber, especially the irrigation levels and how they affect plant size and color. And so we turned that into an interactive. And then we wanted to kind of provide a more holistic overall experience, so the user can take a seed and plant it into a pot and watch it grow in a few seconds, which is kind of cool. So I'll kind of show the process of just how we developed this, and I'll show a little bit of this video. This is when we're doing early development, really it's our team internally kind of pitching these ideas back and forth and, getting a rough proof of concept together. And then, going to the client and saying, this is what we have. What do you think? And how do we move forward from there? So this is just an internal recording I did for my team, and at this point, we're just trying to build some, we have some rough ideas for some interactives. So we wanted to build those and then present that to Dr. Young and his team. So I'll just show a little bit of this, and this is kind of, these are very early stages. So I've got most of the interactives running in here. I've got the light intensity slider here, which will essentially switch between different crop models, 3 different stages, depending on how. Just up until recently, I had this set up where it would do this really cool fade in between to the stages, but it was absolutely killing the performance when I was doing it. And I think it has to do with how I had it set up. VR just does not like alpha channel switching in the materials for some reason. It causes a lot of performance issues. So I switched it back to just popping basically from each stage as you make it brighter or dimmer. obviously these are just stated, all these assets, and I'm kind of explaining this for Lindsay since she's not familiar with game development, but all these assets are just stand-ins. This is just placeholder stuff, so that I can work and add in the scripting and logic to make everything work. And then after everything like that is working well, Jessica and I will go back in and kind of add in all the nice assets and like the scene and everything. So anyway, so light intensity is working. Also got the seed interactive here, like we described, you can pick up the seed, move it, drop it in here, and plant a baby corn basically. So that's kind of like the first stage. I've got the move option here. So if I hit this, it will move the plant along the conveyor belt, and it'll go over here to the, I think I have this designated as the X-ray chamber. And when it passes through, the material will go transparent, so you can see what's going on inside of it. And move it to the next stage. I don't have the speeds adjusted yet. Okay, I won't show all of it, but this is the kind of early development stuff that we do with the team. And so basically, when we got this to a point that we were ready, we kind of approached Dr. Young and his team and presented it to them, and then said, what do you guys think, and how do we go forward from there? So that's when they kind of gave us direction and said, let's focus on the imaging center. We've got a deadline for February, and so let's get that up and going. So primary development is basically fleshing out those design decisions that we make with their team and our team, scripting all the interactive components, integrating all of the content that we want to get in there. And then as the project moves forward, we build everything in-house, or we source it from repositories, but we bring in the nice 3D assets, do all the lighting, all that good stuff. And then testing is a big part of the process, trying to find issues, fixing bugs through repeated playback. There's lots of back and forth with the client through all of this, and it's always helpful to get fresh feedback or fresh eyes, because when you're working on this for weeks or months at a time, you kind of just start to miss stuff. And Lindsay, I'll give her a lot of credit, our science writer. She was basically the liaison between myself and the plant science team, and she has a background in plant science, so she was able to help disseminate the information and make it make sense to me. And I'm a designer, I'm not a scientist, so and so she took a lot of these basically spreadsheets full of numbers and created these nice graphs that we could use in the interactive itself. And then she was very helpful in making sure that the corn models that we were using were accurate, that they, were the right size, the right amount of leaves, that the corn was the appropriate size on the stalk. So all of that stuff is really helpful. And then of course she took, I don't know how many pictures or measurements of the facility itself, but she gave me a lot of dimensions, because when we're building it in VR, it has to be a 1-to-1 scale, for everything to look correct. And, since I'm remote, I'm not on campus, I needed her help to do that. So, so I'll just go ahead and show, this is, so you'll see the difference in just visual quality, but this is basically the interactive from start to finish. I might skip a little bit in the middle and kind of show the root system at the end, but you can take a look at it.
Welcome to Purdue's Phenotyping Facility, Virtual Reality Interactive. Utilizing the power of VR allows audiences to look at exciting and unique features of this world-class research center. Right now, you're standing in a virtual replica of one of the phenotyping facility's growth chambers. They're like greenhouses, except without natural sunlight. This enclosed space gives scientists more control over the conditions for their experiments, like light intensity, photoperiod, water, and even carbon dioxide level. Let's start with a simple experiment. Please grab a seed from the pile by aiming your controller and holding down the middle finger button. Look directly at your hands for key bindings. Everything we do here at Purdue's Phenotyping Facility begins with this, a seed. And for our purposes today, a corn kernel. Please place the seed in the planter and release the middle finger button to drop it into the soil. Then press and hold the right-handed trigger button to water the planter. It can take anywhere from 5 days to several weeks for the corn to reach this growth stage. This is where our researchers begin to alter and analyze various environmental factors to study how they affect various aspects of the plant's growth. An experiment about drought. This plant is part of the well-watered control group, so let's go ahead and apply water until the saturation gauge is full. Notice the soil's change in color. This plant has been watered thoroughly, so let's move it along the conveyor and bring in the experimental group. Let's apply half as much water as the first plant. Could you please irrigate the corn for about 5 seconds? You can see several physical differences between both plants, including size and color. The droughted plant likely won't produce as much corn as the well-watered control group. Scientists can also use the phenotyping facility to study the physiological changes plants experience during a drought that can't be observed by the naked eye. We'll head into the imaging center to take a closer look at some of the technologies used to collect important data. Welcome to the imaging center. Let's continue, shall we? Please note the floating panel in front of you. While the various processes of plant phenotyping are mostly automated in the physical facility here at Purdue, we'll use these virtual panels to control each phase of the imaging process so you can follow along at your own pace. Please aim your left or right hand at the floating panel button labeled Activate and press the trigger button to begin the first phase. All plants in the phenotyping facility are transported on automated conveyor belts, like this one in front of you. The actual layout of the imaging center is a bit more complex, but we've simplified the layout in VR to make it easier to navigate. Our first stop is the RGB imaging booth. Now that our plant is ready, let's go inside to get a closer look. You can move into the booth using either the teleportation function with the right joystick or the continuous move function with the left joystick. If at any point you're unsure of what each button does, simply look directly at your hand in VR, and you'll see indicators for each button. These virtual imaging booths are modeled after the real booths standing in the phenotyping facility. Measuring around 30 feet tall, they were designed with the ability to house and scan a fully grown corn plant. Inside of the RGB imaging booth, the plant is rotated 360 degrees. Every 30 degrees, blue and white lights flash in quick succession while an image is taken. This process is repeated every 2.5 seconds until the plant has been fully rotated. Images are generated for each plant that contain information about the width, height, surface area, and center of mass. This data is
So yeah, we're continuing to develop and update the app. Our next goal is to replace the stock corn models with CN model by the plant science team, and then basically highly active digital twin. And then we want to add some interactive ability to the leaves themselves to let either students or people grab the leaves to identify certain traits or diseases. And then we're also exploring some mixed reality capabilities of the Quest 3 itself for some possible interactive. So there's a lot of cool things that we can do, and we're excited to continue down this road and keep working in the virtual reality space. So that's basically it for my presentation. So I'll take any questions if anybody has any.
Describe mixed reality and for somebody who's, I mean, I can imagine what that is, but for somebody who doesn't know the terminology.
So mixed reality is essentially augmenting virtual on top of the existing environment around you. That's how I would describe it. So whereas virtual reality is you're completely immersed in a virtual environment, you can't see the outside world. Mixed reality is, for example, if you want to lay a virtual game on top of this table here, that's essentially what mixed reality would be. So.
Okay, if I can follow, is that because that seemed to be what Apple was
Yes.
pushing in all their commercials and stuff?
That is what their device does. It's strictly mixed reality. It doesn't do any virtual reality. So, and I think the adoption rate just wasn't there because of the price. There's not a lot of people that are willing to pay $5,000 for basically an oversized headset to wear around all the time. So.
I know that you said Lindsay helped with the sort of communicating back and forth between you as the designer and between the science team. But I'm curious if you can talk a little bit more about that process, because I know for me with infographics, like finding that balance between something that's understandable for the general public, but also making sure it's true to the science can be kind of tricky. It's always a negotiation, and I think every project, how you negotiate that feels a little different. So I don't know if you could speak a little bit more about that.
Yeah, I mean, it definitely, Lindsay having a plant science background made a huge difference because she understood it enough to kind of break it down for me. And with VR, the more interactive it is, generally, the more interesting it is. The difficult thing was trying to find a balance between what's interactive and presenting accurate information. And with the phenotyping facility itself, it's mostly automated. So we kind of, we made it interactive just to make it more interesting. But the actual facility itself is mostly, unless you guys need to stop or do something specifically, it's mostly an automated process. So, we made it more interactive just to make it more engaging, interactive, and bouncing ideas off her and making sure that made sense, and then her working between myself and Dr. Young and his team to make sure that was okay, was very helpful in kind of striking that balance between accuracy and interactive. So
Yeah, I hadn't thought about that fact that instead of just like leading people through a tour, you're also trying to give them something to do
right
in ways that you wouldn't necessarily do in the facility.
Right.
So that is interesting.
right and there's more we would like to do. It's just a matter of time and constraints like that. So
Is there any like sandbox type approaches that are in plan for this in terms of rather than a guided tour?
We've thought about that, and that would be interesting too. We just thought with VR, it's interesting because I always design I always err on the side of this might be this person's first time using it. There's still, VR is a lot more popular now than it ever was, but there's still a lot of people out there who have never used it or used it very little. So the challenging thing for me is, we have to teach the user how to do it while they're in it, whereas most things, to train them, you have to teach them how to do it while they're in the device because they can't see you. And so that poses its own design challenge. And so for us, creating a linear experience was a little more feasible. But I'm not against the idea of creating like a sandbox, more of like, here's a table full of experiments, that you can do kind of thing or go around. It's just that's something we have to discuss as a team and then, work with the client to see if that makes sense on their end. So for this, we wanted to highlight the facility and, give people the chance who otherwise can't go there in person to kind of check it out and, just get an idea of what they're doing there and, why it's important and what's interesting about it. So, yeah.
Yeah, I'm curious about the target audience and distribution. So is this more intended for like researchers who would be interested in this kind of thing or wanting to check it out without being able to come here? Or is it more of like a general public learning about how the plant research works? And do you think you'll distribute it more as like set up a VR system somewhere and have people come use it, or more distributing it, the software, so that other people can use it on their VR system?
So good questions. I'd say it's a little of both. I would say, Dr. You were interested in showing potential clients, like what you guys can do at the phenotyping facility, but then also as sort of an educational tool for the general public. We tried to keep the science, pretty base level so that, almost anybody can understand what's going on there. It is right now we have it up on Meta's App Lab, which is kind of like it's the step before the App Store. But if you have an invite, you can essentially download it. If you have a Quest 3, you can download it to your local device or use it. Otherwise, Dr. Young, he has 4 Quest 3s on hand that he can provide people if they want to check it out. And then our department has a couple as well for testing and development. So yeah, I would say a little bit of everything, if that makes sense. So.
Did you take this to 4-H or?
No, we didn't have it down at the fair or anything like that. So it's only been at the NAPBN conference, which was held here back in February, and then the international conference, which was in Nebraska back in October. So, and while I think we had discussed some issues that we had there, it was a crowded space. There was a lot of noise, so there was a lot of interference, and it made things difficult. So we've kind of talked about that and ways we can mitigate that for future venues that we take it to. So
my next stop is the fish fry.
Yeah, I think there's a lot of opportunity for youth engagement, and I don't know if the grandparents using would be another way to display this.
Yeah, I mean, so when I was working on this last year, I work from home, and I pick up my son from school at 3, so he's usually home for a couple hours while I'm working. And he would come in, and he was really interested, like, hey, that's corn, what are you working on, kind of thing. So I mean, he wouldn't care otherwise, but the fact that I'm doing it in VR, all of a sudden he's super interested in it.
Yeah.
And so to me, I think that's where a lot of the power of this comes from, is just getting kids engaged in the content and giving them a more engaging way to learn this stuff. So yeah, I mean, like I said, a 6-year-old generally doesn't care about corn, but he was pretty interested in it. So
Dr. Young, so I know you give a lot of tours of the facility, and this might, I don't know, how do you see this working into that? To replace it, to augment the tours and provide additional information, or how do you see that integrating into?
Good question. To be honest, initially my thought was not everyone would have a chance to physically come on campus to visit our facility. So when I connect with Tom, my challenge to him is that, Tom, could you create a set of this tool I can demonstrate to people that would not have a chance to come over to visit us? So he did an excellent job here. So much so to the point, I think it's even in some sense even better than even if you are physically on site. Because if you think about the imaging booth, what he can show you, a lot of my potential customers, when they put that goggle on, they were more impressed than people on site. Why? Because they are not able, I mean, when you're on site, I'm not leading you into an imaging booth when my data collection is going on. So I can do all this and say, hey, I have this data that we collect. But on this app, you can visually see, and even though it's virtual, and that's reality actually, it's in-depth reality to demonstrate how the system works and what type of data the system cranks out. Very visually and also very specifically demonstrate. Another example is that in the X-ray imaging booth, it's not transparent in reality. You cannot see what's going on inside. In this tool, you can see how the system works. You can even see how my data is delivered to the end to you, because Tom puts these things together. So in my mind, initially it is a very user target type of product I was asking Tom to please create for us. But seeing what Tom has come up with, this has a much wider market, if you may, to take advantage. Only a couple of weeks ago, we were discussing with Nancy, like the high school science fact. This would be a very good tool to get those kids that are interested, but not have a chance to visit us in terms of what does, nowadays when we talk about agricultural science, what does it even mean? It means a lot. Not only this, but definitely this is a aspect that we can tell the students, you are combining engineers, not rocket science, but it's still pushing the envelope type of engineering with biology, just in this type of system. And you can see that just in one target. So
The root scanning, researchers now, they can view the 3D imaging on a screen, right, of the research. Is there any interest or value in being able to do that in an augmented reality or a virtual reality?
Oh yeah.
Yeah.
They are already, we talk about it.
Yeah.
These are all good questions, first of all. Tom and I, we talk about it because there are already scientists in Arizona and maybe another couple of schools, I don't remember. They are already pushing the envelope, taking advantage of the augmented reality. Basically, when you have your sensing algorithm established, when you have your sensors established, in this case, when you have an augmented reality, you have all the cameras in front of you. It's a see-through type of environment. What if you are doing your visual assessment? In this case, if or when we come to that point, this is I already put on his kind of wish list. You go through your samples. Algorithms helping, but at the same time, you're not waiting till you sit in front of your monitor to see the outcome. You are seeing your plans at the same time you're seeing the potential. So definitely, that's a wish list.
That's exciting.
Yeah.
Any other questions?
All right, one more.
Yep.
Can just one person experience this at a time, or can multiple people join the virtual reality?
So right now it's just a single player experience, a single user experience. But there are capabilities to combine multiple users in a single environment. That's just not something that our department has explored yet, but it is something that can be done. So. Yeah, Russ.
So, looking out over the horizon, I know your research is ongoing in this technology and what everybody else is doing. Any predictions on where you see virtual reality, mixed reality and everything going?
I mean, I don't like to predict the future, but it's not going anywhere. Like I said, the numbers are projected to rise, the amount of users through 2030 and beyond. So it's seen a year-over-year increase for the last 6 or 7 years. So I don't see any reason to think that it won't keep increasing. And, especially if you're, like with youth outreach, they're growing up with this stuff and they take to it right away. So it's a great tool just to get kids interested in learning about this stuff, which I think in and of itself is reason enough to pursue it. So.
You've seen a very short demo, very stream demo, Tom shares with us today. But if you are taking advantage of this tool, what would you like to see actually?
I was thinking, is there a way to do it without the remote and everything?
So
And-
there are hand tracking capabilities with the Quest, and we have considered that too. Because yeah, generally, especially for somebody who's not used to VR, using your hands is much more intuitive than trying to use a controller with buttons. So there's some workaround issues because with navigation, if you take away the controllers, you're limited to the amount of physical space that you can walk through, because you wouldn't have anything to move you. But interacting with things is much more intuitive with your hands than it is with a controller. So that's definitely something we've considered and started looking into. And maybe for specific interactives, that would make more sense, especially if you're, interacting with the plant leaves or analyzing something in VR. Being able to use your hands as opposed to a controller would be a much more ideal solution. So
I was also thinking, like, how they do with houses, do virtual tours.
Mhm.
If you could do that on a computer where you don't have that as much interaction.
yeah, I mean, we could do that, but VR, I mean, like I said, VR is the more interactives you have, the more interesting it is. Otherwise, why are you doing VR?
I was
So
thinking just for sharing.
Yeah. yeah, I mean, you could take the experience and make a video and put it online, but it's not the same as actually, putting the headset on and seeing it in person. So
Another question. Well, I was just gonna respond to your question. In terms of using this, I mean, the thing that comes to my mind is the educational aspect of this, especially for youth. Because, I mean, I'm coming from a social science perspective in my background. I mean, this isn't really my area. I'm here just to learn stuff. But I mean, I could easily see if there's a more robust educational aspect to this. My daughter's 5, and I've got kids that are 3 and 6 months, or almost 6 months. And I could definitely see in the next few years, this type of experience being very valuable to them, just kind of starting to see what this sort of work is from a general perspective.
Yeah, what if you could put some basic capability for someone to create their own experiment, to change the carbon dioxide level and the light levels and just kind of have some simple research that they could do in a virtual environment like that and, quickly see how that progresses in the results. I think that'd be a great science, activity for kids.
I'm sure my son will be very entertained to find out what happens when he drowns the plane.
Or almost like a virtual growth chamber where you could play with the settings in the growth chamber and see the impact of that on the particular crop. That would be interesting.
And that's when we were prototyping, that's kind of in our heads, what we were sort of thinking. We just sort of shifted to this for this particular, launch, but yeah, those are all great ideas and, I'm all for it.
I know from the base project perspective, it makes a lot of sense to be showing the facility because especially here on campus, part of the purpose of the facility, my understanding is to be able to control all those factors.
Mhm.
In VR, I would assume you can still do that even if you're not in the facility. I mean, I guess from a education perspective, it might be a lot more entertaining to have it out in a field. But that still allows them to be able to control all those variables because obviously it's a controlled virtual environment. So
Right.
I think from the upside of the spectrum on the phenotyping research and being able to see like a lot of the details of the imaging. So things like where the cameras are positioned, where the illumination is coming from, you show that it's rotating and all the degrees that it's taking the pictures at. I think just all the details you can have on the imaging setup were helpful to know the utility of the platform.
Cool. Yeah.
I could see it also like with the Semi Lab and food science, like if you could take someone through like product testing and development, like or trying to upscale a small product, like some of it, like using the machine and
Right.
adding ingredients, that kind of
Yep.
thing. Could see that being really fun
Yeah.
way of like learning, but also like feeling like you're making something.
Yeah. I think having a really interactive kind of experiment where you just go nuts and see what you can do to the plant would be, kids would love that. So.
I would also recommend exploring that dual aspect of 2 or more, simply because in middle school, high school, K through 12, they're usually working in teams.
Sure.
So that would be a definite direction to explore.
or parent-child too.
Yeah.
Or parent-child.
I don't know if
any of the data displays were reactive to, for example, you got the two watering treatments of corn.
Mhm.
But, I could see there being an element of like learning how to interpret a basic graph, like greenness or
Mhm.
something like that as well.
Yeah.
We certainly resolve.
Certainly building.
Trying to. Sure.
Right.
Say within 2 or more users, you could also gamify the idea of using the different inputs on a plant to see who would make the most
Mhm.
successful or most productive
Right.
plant, which would also be really
Yeah.
interesting. So helping people understand better how altering the inputs impacts the productivity of the plant.
Yeah, and the gamifying would allow them to have levels of success as well.
Mhm.
And competition.
Farmville PR.
Yeah, exactly. Hopefully easier than Farmville.
Yeah. Great.
So more challenge, huh?
Yeah. More work is always good.
That's great.
Yeah. Well, thanks, everyone. Appreciate it.
Yeah.